So we've worked through how to represent an inequality on a number line, and now in this video I want to show you how we can also represent an inequality on a Cartesian plane in a graphical sort of form. So where we used on a number line, for a less than or greater than symbol, we used an open circle, and for a less than or equal to or a greater than or equal to, we used a closed in circle. We do a similar type of thing with the Cartesian graphs. So with a less than or greater than symbol, we use a dotted line, and basically all that means is the same sort of thing as the open circle, that the line is on the graph is not included, but everything else that's shaded in is included. And with the inequalities that use the less than or equal to or the greater than or equal to, we use a solid line, and that's meant to represent that the line is included and also the shaded section of the graph is included. Okay, so we sometimes refer to these types of graphs as half plane. You might see this terminology somewhere. So they're sometimes called half planes, basically meaning half of the graph is coloured in. Okay, it's kind of, we divide the Cartesian plane into two sections by drawing a line on it, and then we shade half of it. Okay, so we're really looking to graph a line and then decide, do I shade left or do I shade right or do I shade above or do I shade below? And we can do that quite easily, both by hand and also with the calculator. So we'll run through both of those things in this video. So I do want to just explain a little bit about these graphs and how we decide which bit is shaded and which is not. And then I'll show you on the calculator how we can do it. So in this first example, x is less than or equal to 1. Okay, so we could easily do that on a number line if we were talking about x values being less than or equal to 1. We can also do that on the Cartesian plane here. And the way we start with something like this on a graph is to start with the straight line x is equal to 1. So that's what we start with, and the line x equals 1 is a vertical line that goes through the point 1, 0 on the axis, on the x-axis. Okay, and we've done a little bit of that before. You've seen that before, that's not new. So if I said to you graph the line x equals 1, that blue line is what you would graph for me. And then if I change that now and say, no, I don't want you to graph x equals 1, I want you to graph for me x is less than or equal to 1. So the line that we've started with, every point on that line, whether it might be, you know, the point 1, 3, or it might be the point 1, 10, or it might be the point 1, negative 2, or it might be the point 1, negative 8, something like that. Doesn't matter what the y value is. In every one of those points, the x value is 1. So that entire line is included in my answer. And then I want any other point on the graph whose x coordinate is less than 1. So any point that I put over in the left-hand part of the graph, negative 5, 5, for example, or negative 10, 0, or I might go negative 1, negative 5, or I might go, you know, 0, negative 1. Any of those points on the left of that graph all have got x coordinates less than 1. So when I draw this graph of this region, we call this a required region, I would include the line. So I've drawn a solid line on x equals 1, and then I include this entire shaded half of the graph. And when you get into higher levels, you'll need to actually put a little key on your graph and say required region. Okay, so I wouldn't know if I didn't have a key on this page whether the section you've shaded is the required region and the bit that you think is the answer, or if the white bit is the bit that you think is the answer. So you do need to sort of put a little box on the page and say the shaded in part is the required region. And then I know that that part that's shaded is the bit you think is the answer. Okay, so we're looking now at the second example, and you can see that's slightly different number one, because it's a y values we're interested in this time, not x, and this time the inequality has no equals on it. Okay, so I would start this one by thinking about, well, what does the line y equals -2 look like? And the line y equals -2 is a horizontal line that goes through the y-axis at -2. So you know what that graph looks like, and then I need to think, okay, now which part of the graph, which half of the graph do I need to shade in? And I'm looking for y values, so points with y values that are greater than -2. So anything that's above that line has a y value that would be greater than -2. So if I pick a point over here, 5, 5, for example, the y value of 5 is greater than -2. If I picked the value 10, 0, for example, the point 10, 0 has a y value, a y coordinate of 0, and 0 is greater than -2. So those 2 points that I've just dotted on there are in the required region. They're the bits I want, so I know the top half of the graph is the bit I'm going to shade in. And I just need to be really clear on how I draw my line. So in this case, y is just greater than -2, not equal to -2. So my line is depicted with a dotted line. Okay, whereas the one up above, x was less than or equal to 1, so there was a solid line in that example. Okay, and again, I know that the section above is the bit that I'm interested in, and I would need to put a little key that says the shaded in part is the required region. And RR is good enough for required region. You don't need to write the entire word. Anyone looking at that knows the bit you've shaded is the bit you see as the answer. Okay, and again, the third example, and I've spotted just now that I've made a typo when I typed this question, so let's just change this right now so it's easier than. So this one here should be just a less than. Okay, so what the region is here, -2 is less than x, less than or equal to 3. So if you see the difference there between the two lines, the red line is dotted. So that line x equals -2 is dotted. And then the line x equals 3 is solid. Okay, so what I'm looking for is points on this graph with x coordinates between -2 and 3. Not including -2, but yes, including 3. So I go dotted line for the x equals -2. I go solid line for the x equals 3. And then I shade the section in between. So again, that section that's shaded in this case is my required region. So on the calculator, we can do this relatively easily too. So just show you a couple of little tricks with your calculator. When you open a CAS page, a graph page, I should say, and we want to type x is less than or equal to -1, or the entry line on the graph doesn't look very good for doing that. So I need to rearrange that, change it somehow. So if you hit your delete key or your backspace key there, you'll see that you get some options. But they're all y is less than, y equals, y greater than, what. None of them look like what I want at this point. So if I choose relation, number 6, it basically just says, here's an open line, type in whatever you want. Okay, so I want to type, I think it was, let me just double check what it was. X is less than or equal to 1 for that first example. So X, the less thans and equal tos are in the control equal menu. So control and equals brings up all those inequalities. Less than or equal to 1. And when you hit enter, you can see there that the graph shades the required region. The calculator shades the required region. Okay, if you wanted to, analyze the graph and get x-intercepts or whatever, it works exactly the same way as normal. So if I want the x-intercept, menu, analyze 0, and then, I can't even do it. No, I won't be able to do it that way. I'll have to go I can't. I might have to do graph trace actually to see that. Let's have a look. Menu, trace, graph trace. Can I do that? Yes, I can. So sometimes you'll have to fiddle a little bit and see how can I find what I want. But normally the same rules apply as the analysing the normal straight line graph. Okay, if I was going to do the other one, the second example was, what was that? Y is greater than -2. So when I backspace this time, Y is greater than is already an option. So let's do that. Y is greater than -2. So you can see there when you highlight the line, you can see that's a dotted line clearly. Okay, where I didn't show you that one on this one, but when I highlight this line, it's quite clearly solid. Okay, so x less than or equal to 1, solid line shaded on the left. Y greater than -2, very clearly dotted line shaded above. Okay, so your calculator shades the required region. So whatever your calculator has shaded, that's the section that you would write down as your required region. Okay, a little bit more challenging to do the third example. So let's get a graphs page on here. So the third example, the calculator doesn't like when you put it in as one lot of shading. Okay, it won't love it if you try and put that in as one expression in the calculator. So you will have to split it and do it in two. So the easiest bit to see is this one. If you're doing it on the calculator, x is less than or equal to 3 is one part, and then the other part is -2 is less than x. And your calculator, I don't think, will let you put it in that way. I'm not certain. I'm thinking it's going to make you write it the other way. And you can see when we normally write inequalities, we start with the variable. So if I was going to try and write this one, the mouth on the inequality sign is facing the x, meaning that x is the bigger one. Okay, so the crocodile mouth is open towards the x, meaning that the x is the bigger term of those two. So when you're writing it with x first, you'll need to write it like that, so that the mouth of the crocodile is still facing the x, if that makes sense. So the two things you can put into your calculator on the one page and see whether the colours overlap. X is less than or equal to 3. So let's put that one in first of all. So I will have to backspace. That's not the right backspace. That one. And go in relation. And the little inequality you're putting in there, x is less than or equal to 3. Let's type that one in. X is less than or equal to 3. That's the first part of the graph. And then I want to put another graph on top of it. So I'm going to go tab to open up that line again. And my second one was x is greater than -2. Okay, x is greater than -2. And now our required region, it's a bit hard to see it, which part it is. It's the bit that's got two lots of shading on it. So you can see x equals -2 is clearly a dotted line. X equals 3 is clearly a solid line. And where the grey and the light pink overlap, it's this middle section that looks darker pink. That's the required region. It's got two lots of shading. So the bit that's darker than the other two bits is the required region.